Okay, so we're going to do an application problem that involves exact values. We're going to find an exact distance. Allie is learning to play the piano. Her teacher uses a metronome to help her keep time. The pendulum arm of the metronome is 10 centimeters long. For one particular tempo, the setting results in the arm moving back and forth from a starting position of 60 degrees to 120 degrees. What horizontal distance does the tip of the arm move in one beat? Give an exact answer. Okay, so here is a metronome. Here is the arm, which is 10 centimeters long. It forms a 60 degree angle with what I'm going to call the x-axis here. Okay, and it moves back and forth to form a 120 degree angle as it moves to the left. So let's draw in a y-axis, which will be around here. And the arm will move then into this quadrant and create an angle of 120 degrees here. Okay, so if you take a look below, we have a diagram of the situation. Here is the arm to your metronome, and it swings back and forth between the second and the first quadrant. Its length is 10 centimeters, and I will call this point A, and if you drop a line down to the x-axis, it forms a 90 degree angle. And so notice that you have a triangle here. This is called your reference triangle. Okay, and if this base angle is 60 degrees and this angle here is 90, then this one up here will be 30 degrees. And so you can see you have a 30, 60, 90 triangle. Okay, so we're looking for the distance across the top here that goes from point A to point B. And we will start by just determining the distance between A and the y-axis. And notice that that distance is the same as the base of your reference triangle. So if I find out what A is down here, then I will know what A is up here. Now, with respect to the 60 degree angle, you can see that A is adjacent. 10 centimeters is the hypotenuse. Okay, and so if I want to find out what A is, the trig ratio that uses adjacent and hypotenuse is the cosine. And so I'm looking for the cosine of 60 degrees, which is the opposite, the adjacent, which is A, over the hypotenuse, which is 10. Now if you go back to your exact values for the 30, 60, 90 triangle and you take a look over here, it says that cos of 60 degrees is 1 over 2. And so I will just write that over here. And so I can therefore substitute a half in for cos of 60. Okay? So therefore, substitute 1/2 in for cos of 60 degrees because they have the same value. Okay, so in place of cos of 60, I'm going to put a half. So a half is equal to A over 10. And then I'm going to cross multiply. Okay, so I'm going to go 2 times A is 2A, and that's equal to 1 times 10, which is 10. And so A is equal to 5. Okay, but that just gives me this distance here, right? I want the whole distance from B to A. And so therefore, the horizontal distance between 60 degrees and 120 degrees is 2 times 5, which equals 10 centimeters. Okay, and that concludes our section 2.1 on angles in standard position.